This video is just the completion of the 5.5, the previous video. Some sort of computational error in the previous video. I didn't get the mark scheme answer. Just want to check it one more time. The area, we were busy doing the area of ABC. So in order to use the ABC being this triangle, the cosine rule would be a half times 6 square root 5 times 6 square root 5. This is, sorry, not this cosine rule, it's the area rule of sine of this angle. That's this angle A. We're working out angle A, we're using the cosine rule. So we take the line opposite the angle, 6 square root 2 squared equal to 6 square root 5 squared plus 6 square root 5 squared minus 2, 6 square root 5. It would usually just be times square root 5 again. There's two of them. And we have cos of A. Okay, so we just rearrange this. 6 square root 2 squared minus 6 square root 5 squared minus another 6 square root 5 squared, all divided by 2 minus 2, 6 square root 5 squared. This is equal to cos of angle A. I put all of this onto my calculator quickly. I'm just using a Casio calculator. My calculator gives this as cos A is equal to 4/5. So I previously got a half here. So I think I must have just added this incorrectly. The working, it was correct, but something here I added incorrectly in the previous one. Therefore, angle A is equal to cos the minus 1 of 4/5. This is looking way more like it. In a calculator, you can just go second function for cos the minus 1 in once. We get something like 36.869, so on. And you want to keep that there on your calculator. And then we were looking for the area. So the area of this triangle is going to be the sandwich between. So we want this side 6 square root 5, and we want this side 6 square root 5. So here's our area already written, but our angle is now the 36.869 and so on. So on the calculator, you just put a half times 6 square root 5 times 6 square root 5. And then once you've got your 6 square root 5s in, you could just say sine and once, and we get 54, which is the correct answer. So this does give us 54 units squared. Okay, this was correct answer, correct method, just somehow something in my working here went wrong. That completes 5.5. I do want to look at what would have happened if we had tried to use the method of using angles of inclination. So angles of inclination of C, this is equal to this. So I drew a line parallel to the x-axis. And this big angle here is equal to the angle inclination of the line AB, the original line, and so we have this is equal to this. Well, let's see what would happen if we quickly get all the information we need. Okay, so I just collected all the information we need. So this is the inverse line, and this is the original line. And we're going to attempt to use the tan theta equals m to do the same area that we had before. So how would we do it? Well, first we say tan theta of any line is equal to the positive angle of the x-axis. The theta being the positive angle of the x-axis is equal to the gradient of that line. So let's start with the inverse. The gradient is m is a half, so tan to theta equals a half, and theta equals tan to the minus 1 of a half. So this theta, interesting that half comes up again there. So I want the tan to the minus 1 of a half is going to give us around 26 rounded 57. 26.57 or 26.565. Okay. So we know that this angle is also 26.565. We know that both those angles, because I drew this line parallel to the x-axis. Then we do this angle. We do the same thing. So our m is now going to be 2. So tan theta equals to 2. And theta equals tan to the minus 1 of 2. Tan to the minus 1 of 2. Which is going to be about 63.4. Let's do a few points here. 43494. Okay. 63.3. 43. 63 point. And this just be careful, because this is this whole thing. That whole thing. 63.43. So in order to get the angle A, we would have to just minus 63.43, we'd have to minus 26.565 from it. (43494) minus 26.565 is going to give us angle A. I'm just checking that this would give us the same answer. 25.565 is 37.8699. 37.8699. Or 837.87 is equal to angle A. Just for interest sake, so now we have our angle A. Just pause the recording there to fix something. So this is a closer answer that we have there. So it's a half times 6 squared 5 times 6 squared 5. So these are the two sides for doing the area rule, and sine of 37.079. This gives me 54.2624 units. So a little bit off, but with the working there. Interesting, very interesting. Okay, but looking at my decimal points and stuff, not very neat in this one. I would say that using the gradient method is also a good way to get the answer for the area. That concludes question 5. Please like if you like, and subscribe.